Dun 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 dun. Filters are awesome! Let's get this started with already. Contents! Today we're going to talk about Earth physics and astronomy with Sherlock Holmes style. Sherlock Holmes style. Oh my gosh, it's blurry. Now let's get this started with. For now, everything in the world is Earth. Earth. In fact, the stuff inside of your phone is created with elements that are taken from the Earth. However, using those elements and mining those elements is basically really hard to do. And even if we do it, it's really toxic, and it's really toxic for the environment, which means it's not usable or feasible at all. And so what do we do in these situations? We have no idea. Go up and find new places? Well, first of all, let's talk about the Earth and beyond. The Earth is a big blue marble, which is green, and we call it home. And it's home to a bunch of primates called humans, aka us. And yes, we are primates. We are technically monkeys that are intelligent. And if you look closer at their biological stuff, which we'll technically not get into in today's episode, you'll find out that there's a lot about them that we've previously not known before. Now, firstly, the first thing that I really have to talk about is how the Earth works. The Earth is basically split up into 4 parts. Well, technically 3 if you want to go very generally, but if you want to go specific, 4 parts. There's the crust. Let's just say that this magnifying glass is the Earth. It's the crust, the mantle, and the little core, which just imagine is on the tip of my finger. In fact, I have a better idea. There we go. Imagine this big speck as the core of the Earth, and the white stuff that makes things look big is just the mantle, and the black rim is just the crust. In fact, the core itself can be split into 2 pieces, and I'm showing you the inner core. Now, if you want a better view of the outer core, this would be it. I'm gonna have to clean this up later. And with this, you can literally do everything in your power to just try to go here. And this is how geothermal power works. I'm not sure you can see the orange though. Anyways, the orange itself is a pretty big deal, because without the orange part, it wouldn't really make the magnetic field work at all. In fact, the magnetic field is based on and is dependent on the core inside here. And it's because of this core that things are like it is. And without this core, nothing would be the same, because it's because of this core that, well, we have a magnetic field and compasses work. And now that that's over, we're gonna have to start talking about everything else on Earth. Now, Earth itself is on our planet. Our planet is just a bunch of planets, just one planet in a bunch of planets. And right now, the other planets that we know in our bunch of planets is just a planet of a lot of 7 planets. And those 7 planets are just Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, and technically dwarf planets too. Also, we cannot literally classify them as planets yet. Unless we find smaller planets, And then, well, we're going to have to start talking about astronomy. Now, there's a big difference between astrology and astronomy. Astrology is what lots of people think is astronomy. Like, when you say, when is the next rover going to go to Mars? When is the next Mars mission going to happen? When are we going to colonize the whole universe? That's not astronomy. That's astrology. Astrology is a pseudoscience, and it basically is not how science works. It's just what people think is astronomy, but isn't astronomy. Astronomy is just the study of stuff. And astrology is just also a study of space, but it also speculates about the future of space. Astronomy, yes, it talks about space, and sometimes it does involve time travel. That's when physics gets involved. However, most of the time, it's just about the stars and how things work. Now, that might sound like astronomy, and astrology is also about the stars and stuff, but it's more about fake science, too. Astronomy is about real science. In fact, some science facts that are commonly thought to be true aren't actually true in astronomy. And now let's start talking about satellites. This is a pretty short chapter. Satellites work like this. Now, we actually have a natural satellite in the world already. It's the moon. The moon itself is a satellite. It reflects light towards us, and satellites basically work the same way, except instead of sending light, like this magnifying glass does, well, it's not reflecting at all. It sends out radio waves. And it's because of the radio waves that we have Wi-Fi, YouTube, TikTok, my mom being able to order stuff on shopping websites. Yeah, that's why satellites work too. And how they work, like, and travel around, is basically they fall faster than the Earth can spin. Yeah, they basically fall faster than the Earth can spin. And then with this, we can also create the idea of space travel. Space travel still exists. It's a real thing. Neil Armstrong is the first person to be able to go on the moon, and he's basically the first person to go onto another object in space and come back. No one else has done that yet, other than other moon landings. And the U.S. seems to want to be the first country to send a man to the icy places of the uncharted places of the moon itself. In fact, that's what the Americans say they're planning to do, to be the first man back on the moon. Back on the moon after 60 something years. Nice. And yeah. So that's how space travel seems to work out. Space travel, now, here's a problem with space travel, although it hasn't happened yet. If somehow we humans are able to make spacecrafts that can go faster than the speed of light, then we would have problems with time. If you go faster, you start thinking time is slower. Now, at the rate we humans go, it's unnoticeable. But eventually, if we somehow build spaceships that go light speed, well, nearest light speed, then we'll start thinking that 10 years for us will be 40-something years on Earth. Meaning your younger sister could be older than you after just a short trip. And that's not it. Now, I want you and you and you to listen closely right now. Now, you might have heard about wormholes. Now, wormholes, as my mom says she likes, is that you can go faster than the speed of light, and it is a big dream. In fact, yeah, it is a whole big fandom, and right now, wormholes do not exist, or at least we cannot create them. The thing is, wormholes are just pretty immensely terrible to do stuff. In fact, they'll probably close immediately unless we put in dark matter in the middle of a wormhole. And also, there's another reason why wormholes cannot exist. Wormholes cannot exist because if you go faster than the speed of light, which is what wormholes do, you'll basically just be zero mass, meaning you would not exist, you'd be heavier than the universe, and you break the universe. Which is not a good sign. I mean, if you're heavier than the universe, that means you're infinite weight, and second of all, you're a universe destroyer. You're even greater than the Hulk now, or Kong the Conqueror. And that's pretty much it about Earth's physics and astronomy. And so next time you take out your magnifying glasses, don't point it at the ground, point it up. And yes, you can use this to build a fire. As long as you wait long enough. Until next time, people, see you soon. Shannon out. Peace.